We are recording. Welcome to the evening of Python coding. Uh, as always, we have a demo of some Python library. Today, Rakshak Talwar is going to show this recording. Is going to show this presentation. The library this time is about a data library called MODIN. And Rakshak, it's better that you explain. So, Rakshak, to you.
Sure. So yeah, the library is called MODIN. This is the GitHub page for it, and what it does is it lets you just import pandas with just one new line. So you would just do this, and you could use all your panda stuff as normal. And pandas, of course, is a data wrangling library. So it lets you put data into these things called data frames, which is kind of like a glorified spreadsheet in a way, and it lets you do really intricate mathematical operations, and it's very easy to visualize things like charts and graphs with it. And one of the problems that people have when they're using plain vanilla pandas is that it only uses one of your CPU cores. So if you bought a nice, Ryzen CPU with dozens of cores, code here.
Can you zoom in a little bit?
Yeah.
So we can see it. Yeah.
Is that better?
Yeah.
Okay. Sorry about that. Message me when
once people are cloning, we can talk and ask some questions. So
if I can jump in, what is the directory that has the hello world kind of scripts?
Yeah, there's two. They're in there's the data directory, there's modin pandas and vanilla pandas, which are in the parent.
So, Raksha, can you make it even a little bit bigger? Is it possible?
Yes. Let's try 20. Is that better, or should I go even
bigger? I'm okay with it, but some people are still complaining. So, for me,
it's okay.
This is okay. This is big.
Okay. Cool. All right, so I'll go ahead and start. So you're going to go into the generate random csv.py file, which is under data. I wanted to keep the code really simple, so I didn't use any command line arguments. So unfortunately, you're going to have to change this little string here to small, medium, and large, and then run it 3 times. And it'll create, I've already done it, it'll create 3 CSV files here. This might look a little small, I don't know if I can make that one bigger. But it is just large.csv, medium.csv, and small.csv. And I'll show you what it looks like. All it is 2 columns of data. PyCharm is nice enough to color code them for us, but it's just a regular CSV file. There's no special formatting. So the first column is called val1, second column is called val2 because I'm very creative with names. And we're going to perform some operations with this. This is random data. It doesn't matter what the contents are, but I just picked numbers between, I think, 0 and 99 or something when the way I wrote the script. small one's going to generate 20,000 rows. The medium's going to have 20 million rows, and the large one's going to have 200 million rows. And the large one's going to be like a little over a gigabyte in size. So it's pretty simple. I can walk through the code really simple. It'll just check which one it is and then set this variable that have n rows to a number. And that's going to be the number of, we're going to call numpy's random integer function. So you can tell it the range that you want to pick from. So it'll go from 0 to 99 because it doesn't actually count for this number. It goes to the number before it. So it's 0 to 99. And it's going to be that many rows times 2 columns. And I just specify the data type. We don't need to do that. It's just a 32-bit integer. We create a regular data frame. We name or assign names to these columns, val1, val2. And then we use a handy pandas CSV exporter. And so I just run that here. And when you do call the generate random CSV function, make sure you call it from within the parent directory. So if you're using an IDE, you know, you can set it you can set the working directory like that. But if you're just using the command line, just cd into the MODIN tutorial directory, and you can call the script. So I have all the data generated already. I'm not going to visualize the two bigger files because it might cause IDE to crash or something. And before we start, I want to show you this little terminal here. I'm just running HTOP, and you're going to see that because I'm on Google Meet or Hangouts, there's going to be some baseline CPU usage that's going to be pretty evenly distributed across my 12 hyper threads. All right, so let's just get to it. So this is just regular pandas. This is not with MODIN, it's just regular. And all I'm doing is importing that. I'm importing the time library because we're going to use that to measure how fast things are going to see if it actually does speed up things. I'm reading the data. Again, I didn't use command line arguments because I want to keep it simple. So you're going to have to change this variable here from large, medium to smaller, whatever you want to do. And the rest of it can be unchanged. And I'm going to pause it. I'm going to put a breakpoint right here. So we can see what the data frame looks like. Oh wait, this is a large one. So let's start with a small one. Okay, so I'm going to pull up the actual data frame, and you can see the color-coded values, right? Mm-hmm. Okay, cool. So right now I haven't done anything. I just loaded the small, in this case, small CSV file, and I created a pandas data frame with the pandas.readCSV function. And we can see that all the data was imported correctly. So we have 20,000 rows of data, 2 columns. We haven't done anything fancy yet. And I'm going to perform an operation, and I'm going to show you the data frame after the operation. Don't worry about the timing right now because I have breakpoints in. But if I pull this up again, you're going to notice there's 3 columns. There's a new column called sum. And this is just an example, a hello world example of a very simple mathematical operation, and how much simpler can you get than a sum. So all I'm doing is I'm adding every rows val1 column with every rows val2 column, and I'm producing a new column called sum. And the new column name is specified in the assignment site. So sum is equal to val1 plus val2. So 58 plus 9 is 67, and then it just goes on and on and on, right? So I computed that. So that's all I'm doing for both this script and the MODIN Panda script. I'm just summing up the numbers. And maybe one of the things we can try in this presentation, since we have a pretty sizable group, is we can try different operations. And I will try my best to code live, but it might be challenging. So I'm just going to run this program start to end without any breakpoints, without a debugger, just so you can get the baseline time of regular pandas. There's no MODIN in this one. So it looks like it took 4.3 milliseconds to read the CSV file and 1.4 milliseconds to perform the addition computations on 20,000 rows. And because this is regular vanilla pandas, it only used 1 CPU core. And I'm going to run this script again with the larger data, and I'll pull up my little HTOP here so you can see the CPU spikes. but on the small data set, it's too fast for you to see it. I've already run this on my laptop, which has an Intel like 8th Gen i5 with 6 cores and 12 hyperthreads, and I already have my results here. So I'm not going to copy and paste it this time, but you should see pretty similar results, I would say. And I think some people, okay, never mind. So I'm just going to run this again with medium, just so you can see it working. This should also be pretty fast. Okay. So now this took 1.7 seconds to read the CSV file, compared to I think it used to be 3 milliseconds. And the computation took 77 milliseconds, whereas before it took 1 millisecond. The data size, so it was about 77 times slower. And the data size is only, it's 1,000 times larger, but it only took 77 times longer to compute it, so that's pretty good. I'm going to run the large one now, and before I actually run it, I'm going to pull up HTOP so you can see my CPU usage spike. It should spike on one of these cores hard. This one, you see that? Core 3. It's at 100%. The rest of these are going to be low because they're processing the Google Meets. But you're going to notice that Pandas is going to be the one that's eating up Core 3. And it's just going to keep running for a while. You can see how slow it is. It looks like it switched to Core 5. Okay, so it's done. It took 22 seconds to read the CSV file. So just to parse all that text and convert it into the data frame. And then it took another about 1.5 seconds to perform that addition operation. So is there any questions here before I proceed? No? Okay, cool. I'm going to run MODIN again, and we're going to step back up from small to large. And the only difference in the code between vanilla and MODIN is line number 3. So instead of doing, so in vanilla, I'm just doing import pandas as PD. In MODIN pandas.py, I'm doing import modin.pandas as PD, which is exactly what their GitHub said you should do. The rest of the code is the same, which is one of the purported benefits of MODIN is that you don't need to really change your code. So going to start small. And remember, it was 3 milliseconds to read and 1 millisecond to compute with vanilla pandas. Okay, so it took it took 400 milliseconds to read instead of 3 milliseconds. So it took over 100 times slower. And it took another 100 times slower on the computation. So it's not faster. So it's not what they say. And you're going to see a recurring theme here. So I'm going to call it medium now. So how's the weather? I'm just kidding. Took 1.2 seconds and then 0.6. Pretty similar to the small one. So it looks like a lot of that overhead of MODIN is eating up that time. And now let's do our favorite one, the large one. And again, I'll pull up the HTOP so you can see it using up all of my CPU cores. See that? See how they all spiked up instead of just one? So MODIN does use all your CPU cores. That is true. But is it faster? Okay. So I'm going to pull up my results that I copied last time. So when we're looking at the small data set, it's 100 kilobytes on disk, about a little more actually. So MODIN was slower by quite a bit on both reading the CSV file. It was 1.7 seconds, where vanilla pandas was 3 milliseconds. Computation time on MODIN was over half a second, and plain vanilla pandas was about 1 millisecond. The medium data set, we see the same pattern. MODIN is slower on both. Only on the large 1 gigabyte one was something faster. And that was the time to read the CSV file, which was 7 seconds faster than Vanilla Pandas. But you lost all of that gains on the actual computation because it takes, let me see, yeah, again, it took 20 seconds this time too. So it took 20 seconds to do the computation, the addition computation, but Vanilla Pandas didn't even take a second. So I'm not sure how well MODIN would work with more complex mathematical operations. I was very discouraged when I saw this. And MODIN says, oh, you can use Dask or you can use Ray. I actually installed both, and Dask wouldn't even work. So you can actually force it to use Dask, and it will crash, at least on my computer. So you can do that by setting a environment variable called MODIN_engine. You don't need to do this. It'll automatically select it. But if you want to force it on one, you can see this. It'll warn you that Dask is experimental, and then it will crash. So this was very discouraging, and when you go on the actual GitHub for MODIN, you can see that, sorry if I just blinded you right now, it's just going to a white screen from black. But you can see that their master is failing. Their code coverage is mediocre. So I know these projects are, a lot of times they're done by volunteers and stuff, and they all have lives and day jobs as well. So I'm not passing any judgment there. I'm just saying that when you're trying out some of these, I think the learning lesson here is that when you're trying out some of these libraries and stuff, you have to be very critical and try really small, like this Hello World experiment. It only took me a few minutes to code up. But whenever you're trying a new library, it doesn't hurt to just try to see where it'll break, so you can stay on the happy paths instead of going to less explored territory. If it's something mission critical, I do a lot of stuff that ends up in production. But if you're doing more experimental stuff, power to you. But I wouldn't want this in my production setting. I wouldn't be able to sleep at night after this quick little, hello world here. So, do you have any questions? After that, I wanted to ask if you want to try other operations.
I have a question. Actually, I have a story. So,
actually, what?
A story. It's not.
Okay.
It's not the first time I'm seeing some of those parallel libraries take more time than actually one CPU. The question is, and this is more like a discussion, and I want people to say what they think. Where do you think is the overhead? Because I know one thing, like Dask actually has its own data frame that distributes things. So maybe MODIN is sitting on top of it. I know that there are several other libraries that do similar things. They are trying to distribute those huge data sets of multiple machines for a long time. I don't remember which one off the top of my head, but I know they exist. So I've seen multiple of them by now. But Dask specifically has a data frame embedded. So I'm curious why it didn't work, and where do you think the overhead went? Because it did load faster, which is curious because disk is a bottleneck. So I would say that why would MODIN load faster but do the computation slower? Because the CPU has lots of buses that transport things faster. So I would expect the things to be opposite to what we just saw. So what do you think happens without getting into details, just assumptions?
Sure. 1 second. My camera. Okay, sure. It's interesting that you mentioned that, there's two things I want to point out there. So one is, why is it loading faster? So if you look on their GitHub thing, their bragging point is literally read CSV, right? So I would say that because this is their bragging point, some people might just be looking up, Stack Overflow. This is speculative. I didn't look this up, but maybe some people are looking up on Stack Overflow. Hey, why is Pandas reading CV so slow? And then people will say, oh, use MODIN. I think maybe people just open more issues for that because there's an expectation there. That's not a technical reason, but I think human reasons are also very valuable. So that's my answer to that question. And then for the overhead part, I was going to ask you, because you presented on Dask,
Yeah.
And Dask is something that, like, when you presented on it, it really blew my mind and it was really cool. I wanted to see if you had any insight there, actually. So I'm going to turn the question around to you. How does Dask? You said it has its own data frame, right?
So it actually builds on the pandas one. I don't know what happens under the hood, but we're in Austin. It's easy to get to the people who actually develop Desk. Just knock on Anaconda's door, and there's a bunch of them there. And the main developer, I'm not sure where he is now, but check out Matthew Laughlin online. He's nice and he'll answer. And they also have a Dask Gitter channel, so we can actually go there and ask a question. But what I know about Dask is that I use it a lot to distribute computation, and the way I do this, I just send processes. I just like batch files that will run on their own. This is the best way, but Dask actually develops the entire tree of computation. Maybe Modin is doing the same, or maybe it's not doing the same. I'm not sure exactly what's going on underneath the hood there. But I'm seeing, I noticed that Modin has both two ways to actually use it. One of them is Ray, the other one is Dask. This means it's one kind of an abstraction library that like takes two libraries and merges them, like or sits on top of them and allows people to redirect. I've seen this happen in graphics. There's like all the PyVis libraries, or sorry, HoloVis now they're called. They also sit on top of other graphic libraries and just like they're a layer on top of them that you can use and redirect your plots to this library or that library. So maybe Modin is trying to do the same and trying to use the power of the libraries underneath. Maybe this is what's going on. Dask is smart in the ability to actually take and distribute computation to a tree of computations. I didn't use ever the ability of distributed to multiple pandas frames, but it should be able to do this. I don't know how well. I can also tell you that if you try to parallelize outside Dask, I try to parallelize things using all sorts of Python processing. Usually the bottleneck is the data that moves between the processes.
Right, data sharing.
I don't know exactly what moves, but it's like many of them, if I understand correctly, they're trying to like send the entire Python globals and locals between processes, and this takes time. Dask actually has something that does this smarter. It actually allows you to, if you have an imported library, you actually send it to all processing units before. There's a command that does this. Before you use this command, things are slower than after you do this. And Dask also gives you some sort of warnings. So I don't know what's happening with Modin here. I really don't. But maybe a little bit more tweaks there, or trying new things or some other computations. Maybe you'll find where it's better, because the question, I think that what was going on is that you have two data frames and they are both being sent to all of the processors, and this slows things down. Maybe there's a way to do this faster. I don't know. I haven't tried.
The size of the data was pretty small. You know, in the small example, it was only a few hundred. It was like 100 kilobytes. And I did write my own, you know, code with multiprocessing and multi-threading in Python. And I noticed that when you're trying to share, you know, through the queue or whatever data structure that you're using, it's a lot faster with multi-threaded than multi-processed, and it gets exponentially slower as the data size, as the, you know, the payload grows between the processes. It's not linear. It's like, maybe it's not exponential, but it's definitely worse than linear. I don't know if that's the reason for this, because it was only in the kilobytes, and I didn't see like really you know, noticeable slowdowns when I was working on a different project until I got into the megabytes. But how would you, since you've worked with Dask directly, how would you approach scaling up Pandas data frame computations with pure Dask without using Modin?
So they actually have their own data frame. Dask has a data frame that is built on top of Pandas.
Is it completely? Does it allow you to perform anything that
I don't.
Analysis.
I did not check, but they actually have some examples. It shouldn't be that hard to actually go and look at this. But they do.
Yeah.
They do have it, and they do have the ability also to work with other, like big matrices. I recall. I don't remember details. It's been vague, but it's all in the Dask documentation. So maybe in this situation, it's a good idea to go back to Dask and check out what the capabilities are, and communicate with the Dask people. Maybe Matthew will be able to help. I'm mentioning his name because he's real nice. But go to if you go to the Dask GitHub channel, sometimes people help as well. So those are the things that I can recommend. If you don't want to use Modin, maybe try Dask. But maybe it's a maybe. I didn't try it myself. But thank you for bringing this to our attention. Maybe we were doing something wrong, but this small test actually shows things that, yeah, not all Python libraries are perfect, and there's a lot to be aware of. This is part of the, actually, if you're thinking about it, some big bodies that want to use some open source, they usually ask for open source libraries to be, I think the term is indemnified, meaning someone look at them and say this is okay. So this situation, you might want to look at those libraries, and remember, open source is very nice. It develops fast. It does a lot of, it brings us a lot of big, nice capabilities, but it is not something that's always is the silver bullet that solves everything. You have to know what you're doing.
And neither is proprietary.
Oh yeah, proprietary also, yeah.
I've used some pretty bad proprietary software. At least with open source, it's open source.
Yeah?
Yeah. No, I love open source. It's awesome.
Anyone has any more questions so far? Wait a second, I neglected to see the chat. Maybe someone is asking. Alan has found something online. Alan, what did you find? You can unmute yourself. Yeah. I see several people are showing things. Are actually discussing things that are related to you. Maybe it was you. Well, apparently there are some problems that are. You're not the only one who looked at this problem. Yeah. Even very, very, let's say, mature and well-developed software libraries have problems. I remember, I'll mention TensorFlow last year was a little bit buggy, and some things just didn't work. And you can actually go online and see people trying to figure out solutions, but eventually they upgraded to TensorFlow 2, and some of the problems went away. Just went away by the upgrade. So maybe this will happen with Modin very fast. Who knows?
Yeah, I hope it's resolved. And if anyone else had to, find a counter experiment where it shows it being faster, I'd love to see that.
Aha! Here's a challenge for you guys.
Yes, this is your homework.
Just running on a big cluster, and that might work. Maybe
on a big cluster, throw more compute at it.
Like a Dask cluster or something, I don't know. Yeah, but
your mic's a little low. Do you mind raising the amplification?
Yeah. Let's see. Is it the audio or is it the video?
Audio.
Audio.
I think I got a little better. You got closer to the mic, but if you could raise the amplification, that'd be great.
Yeah. Let me.
When you're close, you will hear you.
Even right there, if you just keep speaking, I think you're fine.
Yeah. So yeah, I was making a joke. If you just put it maybe in a big Dask cluster or something like that, maybe it's gonna work. But I'm quite curious right now. I'm probably gonna try it myself and see how it performs with Dask. I heard of Dask, but I haven't used it before, so that might be something to play with.
Yeah, make a PR on the little Hello World GitHub right here that I made. Just make a PR here whenever you find something that's significantly better or significantly worse. Maybe it can fail harder. We don't know.
Yeah, I ran into issues like this. Like, so I had, I remember 3 or 4 years ago, I had, not with Dask, but something else. Like, like when I running on my computer, the typical story, like this running on my machine. But when I moved it to the servers, I didn't see the same improvement, and I still couldn't figure out yet, like why. Like, well, it might be maybe it might be machine specific for some reason or another. But I've seen that this similar problem in the past where I run the same code. I took the same code. I run it like run multiprocessing. You could see that the all these the cores are being used and all that. So when I run on my Mac, I saw like I was getting these like improvements in the performance. But then when I moved it to AWS, then those disappeared. So it might be because I was running in some kind of a virtual environment. Maybe that was the problem. But in this case, yeah, I'm quite curious to see why that is, because this is quite of a yeah. So like problems like this you're gonna see all the time. Like, well, why would it slow down? made me curious.
Yeah. And yeah, just to give more specs on what I'm running here, and I've only run it on this machine, so
yeah,
but it's just an 8th gen. It's an i7, not an i5. Sorry.
i7. Yeah, I have.
But it has 6 physical cores and 12 hyper-threaded.
Yeah, that's exactly what I have here on this machine.
Nice 8th gen plug here. Yeah, so I have that. I'm running a derivative of Ubuntu. It's not exactly Ubuntu, but it's pretty much Ubuntu. Version 2004.
Okay.
Yeah, and I am using a Python virtual environment. So I have a little virtual environment here, and all I did was this requirements, which I also included in here. So just run this. You don't actually need to ask. Ray's perfectly fine.
Yeah, maybe.
And I had to pick this version of Pandas and this version of Modin for it to work properly.
Yeah, maybe
I'm sorry?
Yeah, maybe as Jacob mentioned, maybe it's meant to run on Dask. Maybe there's a certain, or Ray, I don't know what the Ray is, but I heard of Dask. Maybe that's what is supposed to be doing. Maybe it's just a glue between like Pandas and Dask.
Yeah. I think so, right? So I think what they're going for is that people who are doing a lot of data heavy work, they're already using Pandas. They don't want to really change their code because it would trickle through all the code paths that their code would take, and you could the beauty of it in theory is that you just change one line of code at the end, and it's only the import statement, right?
Yeah.
And you don't need to worry about all the transferring over to working with Dask. But about Dask and Ray, so they say that it supports both. When I started running with Dask, I showed it earlier by changing the bash variable, environment variable. When I started running with Dask, it was saying it's experimental, and it would give me a bunch of errors that I didn't want to debug. And so I just used Ray, and Ray just works.
Yeah, I'll try that way. I'll try the way maybe the way it was intended. I don't know if this was the way it was intended, but maybe make around with Dask and see if that's gonna improve things. Yeah.
Cool. Yeah, make a PR if you find something fast.
How did you hear about this library? You just stumbled across
it?
Well,
so when did we first talk? I think it was in May.
Yeah.
Right. Okay. So I just wanted to present something at this group because I thought it was a cool group, and I'm new to Austin and all that, and so I just wanted to be present, pun intended. And so I looked at the list of all the modules that people are presented on, and those were like full of things that I wanted to talk about, full of things that I've already used or do use regularly. But you insisted I have to do something new, and so I just started digging at the bottom of the barrel, and I found Modin.
Well, the idea is to bring something new each time, and this way we explore more and more libraries. And some people who stuck here for a long time continue sticking to this group, probably because we always try to bring something new. So,
have you all heard of MOTW? I think Python Module of the Week. It's a website where they show you the native modules of Python.
huh?
The ones that come with the batteries included, right? The ones that come with Python, like OS or Time or whatever. I've really enjoyed MOTW. Yeah, Python Module of the Week. Thank you, Silas. I love that website. I don't like go on it religiously, but whenever I go, I'm very happy. I'm very satisfied. So, in hindsight, if I could redo this whole thing, I don't know, maybe this was helpful to someone, but in hindsight, I would have actually gone through that and found something really awesome. Oh, thank you, Ellen. I appreciate it. Don't worry about your mic. Your sweet words come through the screen just fine. So, yeah, I mean, I think I would have rather just gone through MOTW and find like a really cool module. I've been splendidly surprised with how well thought out Python is. And it's just like a source of inspiration for me as an engineer to build things very cleanly. I'm like a Python fanboy, so I really love that website. So I'll probably present on something like that again in the future. I like this group a lot.
Okay. Anyone else wants to? We're taking away Rakshak's vacation, so if anyone has a pressing question, please ask now. Otherwise, we'll release him. But you stay tuned. No other questions? Someone's typing.
You're welcome.
You have thank yous. That's good. Okay, Rakshak, I want to thank you very, very much. If you can stop presenting your screen so we'll see you. Here we go. Now we have captured we've captured you on film, and we're gonna stop the recording. We'll upload this to YouTube later on. Stick around,
Awesome.
guys. Rakshak, many applause from everyone. We'll have an echo. But
Thank you.
thank you for taking the time of showing us what MODIN can do, and it's important what you showed. Not all libraries in Python do everything they're supposed to do, and everyone has to test those. So this is a very important lesson for us all. Again, thank you all. I'm stopping the recording now.